continuing our look at exponents and discovering another shortcut. So this is Exponent Shortcuts Part 2. And before we go on to the new shortcut, let's review the old shortcut, the one that we already discovered. So up here in the top, this is what we've already looked at when you're multiplying same bases. And is that what I've got indicated here? We've got a to some power times a to some other power, so we have the same bases. So do you recall the shortcut when we are multiplying same bases? In fact, what we can do then is the base stays the same. That's easy. And then to get the new exponent, we just add those exponents that we have. So this is going to be m plus n. So I'm trusting that you remember that from the previous video. It's going to be related to now what we're doing is dividing same bases. So let's just make a conjecture. What's the relationship between multiplication and division? Okay, they're opposites, right? They're opposite sides of the same coin. So any guesses what we would do with the exponents? What's the opposite of adding? Yeah, subtracting. So let's just see if that works out. So you'll see here, before we take a look at some examples, I've got a to the mth, and that as a fraction indicates division. So we've got a to the m all over, or being divided by a to the n. So yep, we've got dividing and the same bases, both of them are a. So let's take a look at some examples and see what we can discover here. So we've got 3 to the 5th over 3 squared, and you remember if it's a shortcut, that means that implies that there's a long way to do this. So I'm going to do it the long way and see what happens. So 3 to the 5th means what? Well, you know that. It means take 3 and multiply it times itself 5 times. So that's what I've got up in the numerator. 3 squared, 3 times itself twice, and my favorite thing to do in math is to cancel. So we're dividing by 3, divide by 3. Divide by 3, divide by 3. Can't cancel anymore. What do we have left? We have 3 3's left over. So there's my same base, 3. And since there are 3 of them being multiplied, we can write that in a short way, 3 cubed. Okay. So let's take a look at one more, and then we'll talk about the general rule. X to the 10th. Oh, this is going to take me a moment. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 x's being multiplied. Down below, 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me take out my red pen. We can start canceling. This one, another, keep going. This one, this one, this one, this one, this one, this one. We've canceled 9 of those x's. Is anything left over? Yep, there's one little x left over upstairs. So is that what we expected here? So let's see. 3 to the 5th over 3 squared. We know the answer, we figured out the long way, is 3 cubed. Did we, in fact, subtract the exponents? Well, 5 minus 2 gives you 3, so that one holds. What about x to the 10th over x to the 9th? When we're dividing same bases, we're conjecturing that we can just subtract those exponents. The answer we got when we did it the long way was x. So what do you think about that? Okay, when you subtract 10 minus 9, what do you get? You get 1, and x by itself, there's an implied 1. So I think we have discovered our second shortcut. Let's go back and fill that in. So when you're dividing same bases, just what we expected, the shortcut is just to subtract the exponents. And mathematically, how we write that is the base stays the same, a, and to subtract the exponents, and we always subtract this in the top with minus this exponent in the bottom, so it would be m minus n. And I think that's it for this second shortcut. We will continue in the next video where we will take a look at the 2 things that we kind of have to just accept and memorize, but it won't be difficult. I will see you in the next video.